All right, we've come back to the mill, going right back to our setup on our 3-jaw. I haven't reset the DRO, so what I'm able to do is just take my 1/4-inch drill bit and line up one of those holes right there, and then I've got the chuck nice and tight there. So we're lined back up, we're still on center, so we can go ahead and remove this setup, and what we're going to do is go in there with an end mill. So I have looked around for some candidates for some milling. I've got 2 end mills that I think might work. We're going to start with this one here. This is a 1/2-inch roughing end mill and plenty of flute length there. And the only problem I have with these long mills is that you get deflection down here on the end, plus you get chatter. But with the roughing end mill, you get a lot less chatter than you would with the regular helix fluted end mill. But we might be able to get in there like that and do our milling. We don't have a lot to come out of there, so my plan is to start from the center and offset to one side in the center and conventional mill to each side. Okay, so we'll move over that way, and then we'll come back over here. We'll come over here to this side and move that way, and then move back over, that sort of. So I always want to be in a conventional milling or a push milling manner. So if this end mill doesn't work, if it tries to not clean up the radius in the corner, I have one more that I think will do it. We can step down to this 3/8 roughing end mill, and that one will also reach down in there as well and clean up that corner if the 1/2 inch is too big of a mill. All right, so we'll get this set up and I'll bring it back. All right, I'm just showing you the DRO here. You see I've got my note on here. 0.455 is our target dimension that we're going over to, and once we go to 455, that should put us on our 1.410 cross width, on the flats there. So, we'll start to 0 on one of them, and then we'll work our end mill over to 455, and then work our way over on the other axis to 455, and that should clean up 1/2 of one flat on it. The shot here is really going to kind of suck getting in there. We're in a blind hole, so it's hard to share it with you, but I'm going to do the best I can, guys. I've also got my mini cool in there to try to help clear some of the chips out of the way, and just a little bit of mist there to try to keep the cutter cool. So let's roll with it, see what we can do. Wrong direction. There's 455. All right, let's move it over. Wow. Already messing up. What the heck was that? All right. That must have been the cutter grabbing and snatching. All right, we're still squared up, and what I decided to do is just kind of do it in some steps. So I took approximately half the depth instead of cutting it all at one time. The other thing I can do also is go in there and actually plunge with the end of the mill and try to remove the bulk of it. I went ahead and sped it up a little bit too. So we'll go back over to this side. I was testing one side to see how it was going to do. All right, we made it back to our starting location right there. All right, so there's you a lot closer look at what we're doing there. Let me get it focused in. All right, it looks like the mill did a good job, and I'm not sure, I may still have to go in there and use that 3/8 end mill to get all the way to that corner there to clean it up. But you can see I didn't quite take half of it, so I'm going to do it in 2 more steps to get to the bottom. If you look down there in the bottom, you can see what happened. The end mill was flexing, and it dug into the bottom down there in the very bottom. I didn't have enough clearance down there. I had touched the bottom and then brought the table down 2/1000ths, but apparently that wasn't enough. So I'm just going to carry on getting it roughed out like I'm doing right here without the camera in my way so I can see better, and I'll show you guys how it's turning out once I get it all roughed out. All right, so this is it completely roughed out. We're probably going to have to go in there and make another really light cut around the sides, but I think we're going to be able to get it with our 1/2 inch end mill. So here's our tap that we're using for our sample, and you can fit that in there, and it just tries to barely start down into the slot, into the square drive, so it's telling me that I've got a little bit more to come out of there. So we're going to have to make another little pass around the side of it and get it cleaned up. You can see that spot down there in the bottom where that end mill had grabbed, right there. So I'm going to make another pass around it very lightly, and then we'll check it again. All right, just a little update. I went to my 3/8 roughing end mill, and I've been skinning out just a couple thousandths per pass around there, and I've just about got it. I actually switched over to this tap right here because this shank and everything is nice and clean, and I'll show you where we're at right now, and I'll also show you our 1 7/8 diameter fits really good right there. All right, so we can line it up on the square and drop it in, and I've got not quite a 1/2 inch there to go. I've got a red line on the depth, and I don't want to get it stuck in there. So it's part of the problem with the long end mills is the deflection that you get. So you're usually milling a little bit small at the bottom there than at the top, and there's really no way around it for me. This is the best setup that I got. Using a nice long rigid carbide end mill would be the best way to do this, but this is the best way I got to go about it. So I'm gonna take one more little pass around there and take an extra 2/1000ths out of each side, and I'm hoping that allows it to open up to where the tap will drop in there. All right, one more pass around it. Took 2/1000ths off each side. Look at that. That looks like we got us a perfect fit there. Still a little bit snug. Yep. Wow. Looks like I'm gonna have to make another pass, I guess. It's a little bit too, I mean, it's a good fit. It's a good rigid fit. It goes right in there, see? It goes right down. We may leave it as is. I haven't decided yet. It wouldn't hurt to have another couple of thousandths out of the square total. All right, I think that was my last pass there. It seems to be fitting. It seems to fit nice now. Get it in there, I'll show you. Goes in there good, and it comes out. So I'm gonna leave it right where it's at. I am happy with that. I mean, it's just as rigid in there as can be. So that part is done. All right, so next phase of it, we're going to pull this out of there, and then we've got to mill the square shank on the 1.5 inch portion of the adapter. And then once we get that, the last thing we'll do, I'm going to set up the super spacer to do that square there instead of using this here, because I need to put a 45-degree angle on part of that, on part of those flats. And I also have to put 2 1/2-13 set screws in here, so super spacer will be a better job to hold it for that. All right, so we'll get this broke down, bring you guys back once we're ready to start that other square. All right, we got the super spacer set up there, get the part clamped in. I believe I'm going to use this indexable end mill right here to do the milling. Takes the TPG 300 series inserts. We'll give that a try. Hopefully that'll work pretty good. And then as far as squaring it up with the internal square shank, I'll show you. We looked right through here, and I'm going to quote the words of my buddy Jimmy DeResta: if it looks straight, it is straight. So I've spent some time here getting it squared up as close as I can by sight, and we've got it chucked up. So it should be nice and square to what we're going to put right here. We got a 1-inch wide flat, and then this right here where it transitions up to the shank, we'll have to mill a 45 right there. I don't have any, I've got an end mill that we can use to cut the 45, but we'll have to do that as a second op after we mill the flat. We're going to start with half of what we got to do. Total depth of 202, so I'm just going to split it in half and see how it does. Get everything ready to roll. Okay. We're going to go ahead and do all 4 like that with half the depth. I don't want to take it all at once. So 270. Maybe I should go the other way so I don't screw up. So we want to go 90, 180, 270, 360. To 270 right there. I like to click it in. All right, as I said, we took half of that. I didn't want to overload the mill or the cutter, so I just measured this way at 1.335, and it looks like we got this one, same thing, 1.335. So I've done the math, and that puts us still at 105 each side to come off there. So we'll go ahead and finish this guy out. Trying to make nice even cut across there. Just like that, finish it out. Looks like I got it on 1.124. So 1 thou under what I was shooting for. Yep. Let's check the other way. See if it's consistent. Yep. 1.124. All right. Well, I think that's gonna work just fine right there. So now we need to swap this cutter out. I've got a 45 end mill that we're going to use, like a chamfering mill, that we'll use to cut this angle right here on the radius. All right, here's our 3/4 inch 90-degree end mill there, 2-flute end mill. I've got it pretty well set by sight there that I think that it'll blend in pretty good. Let's go ahead and give it a shot. See how it does. We've got everything locked in and ready to go. Looks like it's doing a good job. Come back across there and clean it up. All right. That looks really nice. I think I got it first shot there. All right, let's go ahead and we'll index it and we'll do another one. We're on 0, we'll go to 90. Let's do it again. For an extra little special touch, let's break that square with the cutter here. Make them all look even. It's not necessary, but I just thought I would do it since I got the cutter already set up. Well, all of our square milling is completed now, so we'll take it out of here. Take it out, we'll get all this cleaned up, and then now what we'll do is go ahead and drill and tap our 2 set screw holes. They'll be 90 degrees apart, so we'll just put it right back in here. I'll find the center using an edge finder. We'll line up on this flat here, find the center, drill and tap it in 2 places, just right here in the mill. So here's one little nifty way we can level up the flat inside there, so that we know that our set screw is going to be perpendicular to it. So I've got there's a parallel on the bottom, and this is an adjustable parallel on top. That way it just squeezes everything tight against the top and bottom flats there. And I've just got this little level here that we'll use, and we'll rotate. I've got it just barely unchucked, so we'll rotate it in about like that, and let's tighten the chuck and see if it moves. It's man, it's off just a skosh. Let's see if we can get it since I got you on film here. All right. Well, I think that's going to be close enough. But anyway, just one little trick there. That's it's not super critical, but you know, this right here, you know, we're going to be very, very close to being square on those flats. All right, we're ready to do our set screws. So what we'll do, we'll go ahead and spot in both of them lightly with the center drill. Then we'll go with our tap drill, and then we'll tap them. So all I'm doing there is just, well, that thing is not, I feel like that center drill ain't ground in the center itself. So we're just putting a spot there for the tip of the drill bit to follow. Just like that. 27/64, I believe. Yeah. All right, and we'll back it off to our, which way? We'll go this way. To our 0, and we'll drill this one. All right, let's hit our chamfers. That looks good. Remember, the little bit's going to be skinned off that OD there. All right, and then we've got a 1/2-13 gun tap. We'll just do our power tapping right here. All right, well, that completes our mill work. So I'm gonna take this thing out, go get it cleaned up, and then I'll meet you back at the lathe so that we can go ahead and skin our ODs down to our finished size. All right, we're chucked up in the 6 jaw, and I was going to show you this. So this is chucked up, and then all 3 pinions snugged up squarely, and we've got 1/2 thousandths run out there on that shank. And this should actually be good enough for what this is. A tap driver, this is going to be fine. But let's go ahead and see if we can tweak this. I'm going to be using the, Set True backing plate on this and see if I can get it any closer. Usually 2 to 3 tenths is about the best that I can get this thing to get within, and it looks like that's where we're at right now. 2 to 3 tenths. So that's going to be fine. I just kind of wanted to show you guys. I haven't shown that in a while, but that's how this is designed so that you can actually, you know, dial in that thing if you need it to run absolutely true. So we'll go ahead and I'll skin this, cut the angle right there, then we'll flip it around and chuck this, and then finish out the shank. We had about 25 to come off, so I dialed in 15 right there. So I'm going to back off like that, and then we'll finish taking what we need to get it the size there, 2.5. So. So we are spot on 2.5 inches. All right, so let's flip her around and finish out the other side. Try to give himself enough room to get in there and cut this. I think we can reach over there with a nice tool to do that. All right, we're gonna have to, we'll move it because now it's showing a 1,000, so it didn't repeat very good there. Actually, I'll do this. I'm gonna unchuck it because sometimes this works too if you loosen it up. And that could have been some error that I was indicating on earlier as well. Make sure I'm off that set screw hole. That's less, but let's go ahead and do some adjusting here on it. Oh, see, wrong way. Always go the wrong way. Let's back that one off. Tighten on that one. Looks like 2 or 3 tenths right there. That's about as close as I can get it. I keep reading the indicator wrong too because each line is a 1/2 thousandth, so we're in between the 1/2 thousand lines right there. So we're going to call that one ready. Get them chips like that. I just like to stop it as soon as I can and get them off there, just like that. All right, well there she is. I just hit it with some Scotch-Brite there to brighten it up, polish everything up. It looks good. All I need to do is blow out the tapped holes and go find some set screws for it, and we are done. Well, here's our completed tap adapter. Everything is finished, and I'm happy with it. I think it turned out pretty good. As to the print right there, I've just got that one mess up down in there where the end mill touched the bottom, but it's not going to hurt the functionality of it. It just hurts the pride a little bit because I always try to make a flawless piece whenever I can. But it's going to work good. I've already actually stuck the tap in there a couple times just to be sure that it fits, and it works good. So the tap holder has arrived, and so I'm going to go ahead and we're going to test fit that. But first, let's go ahead and use my Buckeye engraving maker's mark, and we'll use our Dake arbor press here to just press our mark right there in the very top. I'm just going to put it right there on the very top of the square shank. It's the best place to put it right there because it's going to be easy enough just to press on it right there. We look good and lined up. Everything kind of looks square with each other, so let's go ahead and put some tonnage on it here. Okay. Okay, hopefully that did it. I could have pressed a little bit harder than that, but we got it in there. So we've now got it marked. Here's our new tap holder right here for the 1.5" NPT taps. And of course our new adapter that we made. And I'll show you, this is an 1.5" NPT tap that will stick in here. You can see it. Gotta get it lined up with the square shank. And this being such a short shank right there, it's a little tricky to use them because they're up so close to the threads right there. That's why a lot of the taps that you see used in these holders are those high performance spiral fluted. I'll pull one out right here. So I haven't shown this one yet, but this is my 2" OSG tap, and this is the style that worked really good with the Flexarm. So you got these extra long shanks right there, so that you got a little bit extra reach coming out of the tap holder. But one of these days we're gonna get this one set up and tap some holes with this guy. But for now we're gonna focus on our NPT. So go ahead and pull this guy out of there, and then we've got our new tap adapter that we will put down in here. Get it lined up with the square. Where are we at there? Come on, there we go. All right, so there we got a good fit, and that's just how it'll work. It'll go up into the Flexarm like that. We'll go ahead and stick our 2" tap in there as well. There we go. And then you got a set screw there. Use a 1/4" Allen wrench right there just to snug up the set screws. Then that just kind of holds it in place. The square is what drives it. So there it is. There is the setup for the Flexarm. That is very cool to be a part of this little project here. That's going to be for a launcher, and I'm looking forward to seeing the completed unit from Flexarm, their whole entire fixture that they're building for them for this project. All right, let's go ahead and we'll mount this in the Flexarm so you can see how it's actually used in operation. All right, so here's my Flexarm right here. This is the GHM 60. We'll tap up to a 2" tap or 2" NPT. Let's just hold it. There we go. Just got to get those keys lined up. So there it is, mounted in there. Got a little bit of weight there to it. I haven't got a counterbalance for this extra weight right there. Just for the smaller holders and the smaller taps is what I've got it. You can adjust the arms there, the dampeners. So let me go ahead and set that down, and we'll go ahead and fire this thing up. All right, here we are mounted up. I'll give you a little spin test. And of course, variable speed power unit right here, so you can adjust the speed whatever you need to. Same thing with reverse. And the way these things work right here, these tap holders, you've got a slight amount of float built into those things. So, these taps center up on the hole, and they self-center. And with the spindle allowing it to slightly float a little bit, it pulls down in there nice and straight, right in with the hole. So this is going to be a nice unit to have right here. And this is definitely the way that I want to be able to utilize my Flexarm in the future. If we've got some, NPT holes to tap, even the smaller ones, if you're doing 1/2" 3/4", 1" pipe, this would be the way to go right here, because it takes a lot of torque to spin these taps, these NPT taps up into a hole. So using the hydraulic power on the Flexarm, definitely the way to go right there. Well guys, this job is finished up. This has been a fun project, and I really appreciate Flexarm working with me and wanting to collab with me on you know, just even a little small part like this that's going to be used on their you know, their big fixture that they're building for launcher. You know, just kind of, you know, being a part of the launcher project, even a small piece like this, I think is pretty cool. You know, just something that you know, a manual machinist like myself built in his humble little shop at home, that's going to be used for building parts that's going to be launched up into space, and I think that's really cool. So I appreciate, you know, being a part of it, you know, and the guys asking me, do I want to you know, help out with some of the components on this. So you never know, maybe that opens the door for you know, being able to work with them later on in the future. You know, another collaboration, maybe do some machining on something else. You never know what's gonna, you know, the possibilities that are out there. But anyways, I hope you guys enjoyed watching this little build and this project, and come on back for some more. I got plenty to do, and we'll see you on the next video, all right?